So first of all, you are good with graphing them. Okay. So my comment for you guys when it comes to graphing, I've had this conversation with a couple people. I think some of you probably have heard me, but I want to repeat myself just to make sure. When I'm correcting your test, and I give you one of these are the things that I'm looking for. I'm looking to see if your increments are reasonable. If your data is like 1.2, 1.7, 2.3, 4.1, like it's decimals, I would expect you to not count by 2s, right? I would hope that you can count by 0.5s, so you could distinguish between like 1.2 and 1.6. Like you'd be able to distinguish between those. That's the first thing. So I'm always looking at your increments. Once I've done that, I'm looking at, did you graph your points properly? Okay, so that's the next thing I'm looking at. If those are all good, then I'm looking at the 2 points that you chose. You have to draw a line all the way through the data, through those 2 points. Because if those 2 points create a line that is way too high or way too low, or kind of skewed differently than your data, that it doesn't represent the data, you are going to get marked down. But once you do that, then I will look for whatever you do for your line, whether I think it's the right place or the wrong place. That gets graded on its own. And then I look at your calculations for writing your line for that equation, okay? So each of those things I kind of look at separately. If you don't have a good line, but you have your equation, everything else after that just based on your equation. Does that make sense to you guys? Okay. So for number 18, here is the graph for 18. I'm just going to use this as my guide, the graph that they gave me. Now, if I was creating this graph, I would not have counted by thousands. I would expect you guys to count by maybe 500. How many of you guys counted by 500? Sweet. Because then you can see the difference between these two right here. And you can see the difference between these two right here. That's kind of what I would expect, okay? So, Rita, can I use yours? Let me take a look at yours. I'll just use yours as my guide. Thank you. All right, so if I use her graph for 18, okay. So she used these 2 points. All right, if I look at her line, I feel like her line follows the data. How many of you guys agree with that? Okay. I feel like she's got a couple above, a couple below these 2. Now the one thing I would tell you is draw your line through them. So I know that's really picky, but if you look at this now, and this is what I did yesterday, I could tell that mine wasn't really drawn really nicely. I'm going to use the excuse because I didn't have my glasses. I'm totally going to use that excuse, but other days when I don't do it, I can't use that excuse. But make sure it's going through there because then you're reading your graph more accurately. But having said that, I do agree with your 2 points. Okay, so I'm going to write down what these 2 are. Can I write on your paper? Okay, so this is 2, 4, 6, 8, 10, 12, 14, comma, 1700, right? All right, and then this one is 14, 16, comma, 3500. Okay, so I'm going to freeze that, and then I'm going to use that. So here we go. I'm going to write those down. So we use the points 14, 1700. How many of you guys use those same points? Awesome, okay. So whatever points you used, this math is going to be the same. Yes? Was it the higher one? Okay, we'll go with that. Because it was the higher one. Excellent. Okay. So if I used these 2, my slope is y2 minus y1 over x2 minus x1. So I'm going to do 3,500 minus 1,900 over 16 minus 14. All right, so I have 3,500 minus 1,900. That gives me 1,600 divided by 2. So my slope is going to be 800. So that's what I got for my slope. Let's look at what they have. They used 513, all right, which means they used totally two completely different points. Okay, if I take a look at their graph, because I want to make sense as to why. If I take a look at their graph, because their points are so not spread out, can you see how they could use two completely different points than you? Right? So they could very possibly, it's a flatter slope, so they could very possibly have used maybe this point here and this point here. So they could have done a line because of how they made their that does that. And I feel like that's going to give a different slope. Yours was a little bit steeper. All right. My opinion, because you counted by 500s, my opinion is that yours is going to be more accurate. Okay, that would be my opinion. All right, so that's what I get as my slope. All right, and then I would go from there in using that slope. Okay, I'd find my B value and go from there. So I think somebody else asked me about this problem too. Elle, was that you? Okay, so to me, that's the reason why. But now you guys kind of know how I am looking at your work to see what your work is. It is all very individual based on the 2 points that you use. Okay? Some of you we may find on a graph that all of you are going to use the same 2 points because they're so obvious. But if it's not, as long as I think it looks good, you graphed it right, it looks good, you used the right 2 points, everything else there I'll be graphing based on those numbers. Okay? All right, what else can I do for you guys? You guys pretty good with these? Okay. Get your notes out and let's talk about what's going to be on your test. All right, so today's the 10th. This is our chapter 4 test summary. Okay, so I'm going to try from now on, instead of saying just 1, 2, 3, 4, I'm actually just going to list it by sections. I think that might be easier for you guys because you know what sections they come from. So from 4.1, all right, this was slope-intercept form. All right, here we were writing equations. Given slope and y-intercept, 2 points. All right, we looked at function notation here, just so you recognize what it is. I mean, there's not much you have to do with it, just so you understand what it looks like. All right, and then we had story problem. The biggest thing I want to remind you about slope-intercept form and story problems, y as a function of x. You're going to look for that phrase because that indicates slope-intercept form, okay, in story problems. And when you see it, you're like, sweet, it says it, because then you know exactly what your y information is, you know exactly what your x information is, you know exactly the form you have to use. That makes life a lot easier when you see that. All right. Your slope in a story problem is always a rate. That's something to remember. Your y-intercept, that's always going to be a one-time cost, a one-time fee, an initial amount, initial number of people, the weight of an animal at birth. All right, initial amounts, so those are y-intercepts. Okay. From there, we looked at in 4.2 slope-intercept form. Every year, I question whether I need to teach you slope-intercept form, only because it's not all that common. It's just handy, because if you're not given your y-intercept, you don't have to find your b value through slope-intercept. Did we do slope-intercept form? Did I skip it? Point slope. What did I'm saying one thing and in my brain we're doing another. Point slope form. Sorry. Point slope form. Phew, let's rewind for a second. So point slope form, we did do that, right? Okay. So point slope form, it's just handy. You know, slope-intercept form is the most common when you have independent-dependent relationship. Standard is when you have two independent. All right, so point slope form is just kind of handy to put it into, and then you can change it from there into slope-intercept. All right, but point slope, if you remember, it's y minus y1 is equal to m times the quantity of x minus x1, where x1 and y1 is any given point. All right, again, we would have story problems, but more likely, all the story problems for point slope and slope-intercept are exactly the same story problems. Okay? In the end, I want the equation in slope-intercept form. Okay? If you put it in point slope form first, that's fine with me, and then you turn it into slope-intercept, I don't really care. But in the end, if it says something as a function of something, you're ending in slope-intercept form. Okay? The one thing that is common between both of these types of these forms is you have an independent, dependent, info relationship for both of them. So like I said, the story problems you have for slope-intercept would be exactly the same story problems for point slope. They are pretty much interchangeable. Okay, one of the things that we did, 4.2, this was actually 4.3 is point slope. 4.3 is point slope. I'm going to say 4.1, 4.2 is slope-intercept, because both of those were slope-intercept. All right, one of the things you need to do, I'm pretty sure it was in 4.2, all right, but one of the things that we talked about was beating up a table. So beat up a table to determine if it is linear. In one of those two sections we did, one of those three sections, I think it was 4.2, we were doing that. And if you remember to do that, I'm just going to set up just a generic table. You need to find your change in your y and your change in your x, because you're looking to find your slope. Slope is change in y over change in x. And you're looking to find the individual slopes. All right, if all the slopes are the same, it's linear. If all the slopes are the same, the table is linear. Okay. From there, 4.4, we started looking at standard form. Who needs to see what's up there? Okay. So 4.4, and I know that's the right section, 4.4 is standard form. Remember that AX plus BY equals C, where A and B, these are both rates, and C is a total. All right, the big thing about standard form is that we graph your X and Y intercepts. So when we graph that, we graph the X and Y intercepts. All right, in this we talked about horizontal lines, horizontal line equations. Horizontal lines always cross your y-axis. So these cross the y-axis. So it's always y equals some number. That's one way to remember what a horizontal equation is. It's always y equals because it crosses the y-axis. So for example, y equals -3. All right. Well, this line crosses y-axis at 0, -3. Vertical lines are the same. Vertical line equations. Well, these cross the x-axis. So, God bless you, it's x equals some number. All right, for example, x equals 6. This crosses x-axis at 6, 0. All right, you are going to have a story problem from standard form. All right, you're looking for 2 rates and a total. So you're looking for 2 rates and a total. That's what kind of tell you that you have standard form. All right, and our information, so we have 2 independent information groups. So X and Y are both independent. That was like we did the number of people in small vans, the number of people in large vans. Or the number of vans you need. So there's 8 people per small van, 12 people per large van. X and Y are your number of large vans and small vans. One does not always depend on the other. Yeah. No, I will not give you a percent problem. Those are funky, aren't they? Yeah, no, I'm not giving you those. I don't even like those. All right, who needs to see what's up there? Are you good? Awesome. All right. So 4.5, these were parallel and perpendicular lines. Remember, it's our slopes. So parallel lines have same slope. All right, perpendicular lines slopes are opposite, reciprocals. Not just opposites, not just reciprocals. Opposite reciprocals. Both. All right, in this one, you want to write a line parallel or perpendicular to a given line running through a given point. All right, you might have to determine if on a graph if two lines are perpendicular or two lines are parallel. If that's the case, you're just comparing their slopes. Right, so for parallel and perpendicular lines, you're just dealing with their slopes. Okay, the last sections, I'm going to lump these two together, 4.6 and 4.7. All right, these are scatter plots and lines of best fit. All right, you are going to be given one of these, and you are going to have to create a scatter plot from a table. And you are going to have to write an equation for line of best fit. And then you're going to use the equation or graph to predict. You're definitely getting one of those. But I feel like you guys are really good with those. So that is, in essence, is your test. So story problems are going to be a slope-intercept form story problem, a standard form story problem. You're going to have to compare whether, in some way, shape, or form, if lines are parallel or perpendicular. You're going to have a scatter plot. I mean, essentially, that's your test. Is there anything on there where you're like, no, I can't do that? Or are you guys pretty confident with most of this? Pretty confident with most of this? Okay. This chapter review is the minimum. I'm only checking that in, but I would take time to kind of predict what problems I'd put on your test. I'm not putting a percent problem like those percent of fluids. Do not waste your time on those. I'm probably not going to put one of those travel ones on there because I don't think those are really traditional standard form equations. So I'm going to put a traditional standard form type equation on the test. Okay, so don't worry about those. Remember from that worksheet, just forget those on those worksheet. Go to the other ones on that worksheet or what we had in our just in the sections for story problems for those. Okay, I feel like there were two different sections, 4.1 and 4.2, for slope-intercept forms. So I think you've got a couple, and then point slope, which are the same equation. So you've got several you can choose from to practice for your slope-intercept type equations, and then you have the one section for standard form. That's it. Not so bad. All right, you guys are good to go. We can just hang out for a little while, unless you have certain things you have questions on that you want me to go over. Natalie? Yeah? If you guys want to start working on it, you've got 8 minutes.